Today I'm going to talk about recursion, which is a programming concept where a function solves a problem by calling itself. It sounds confusing at first, but once you see how it works, it's actually very logical and powerful. Recursion is when a function calls itself to solve a smaller version of the same problem. Instead of solving everything at once, the problem keeps getting broken down until it becomes simple enough to solve directly. Each recursive function has two essential parts: the base case, which tells the function when to stop, and the recursive case, which is where the function calls itself with a smaller input. Without a base case, the function would run forever, which would cause the code to break. A simple example of this is calculating factorials. The factorial of a number is that number multiplied by the factorial of the number before it. Each recursive call reduces the number until it reaches 0, which is the base case. As you can see here, the factorial of n is equivalent to n times every single number before it. So the factorial of 5 would be 5 times 4 times 3 times 2 by 1. If we keep calling 5 times the factorial of 4, and then the factorial of 4 is 4 times the factorial of 3, we keep breaking the problem down, which makes it easier to solve. You can visualize recursion like a stack of tasks. Each function call waits until the next one finishes. Once the base case is reached, the answers start returning back up the stack until the original call is solved. Recursion is especially useful for working with data structures like trees and graphs. It is also used in algorithms like merge sort and quicksort, where problems are naturally split into smaller pieces. Recursion and loops can often solve the same problem. Recursion can be easier to read and understand, but loops usually use less memory. Choosing between them depends on the situation and the problem structure, whether you want to prioritize efficiency or you want to prioritize readability. Now, one of the biggest mistakes with recursion is forgetting the base case or never reaching it. Another common issue is not reducing the problem size, which can cause a stack overflow and crash the program. You should be using recursion when the problem naturally repeats itself, like navigating folders or processing trees. If performance is critical and the recursion gets very deep, a loop might be the better option. To sum it up, recursion is a technique where a function calls itself to solve a problem. It always needs a base case. It's very powerful when used correctly, and understanding it helps you think more clearly about problem solving in programming. Thank you for watching.